Okay, so our example. Our example actually uses functions. So by a quick show of hands, who's worked with named functions before in any programming scripting language? So a few people, a couple key people who haven't, but assuming a high level of knowledge, then we'll help out those that aren't getting it as easily. So here's a really simple example of a function. You can declare a function in almost any place where you can write actions in ActionScript. Syntax is, like most things in Flash, identical to JavaScript. We use the word function. We come up with a unique name. And then we optionally have an option for parameter passed in. We'll come back to that in a second. Here, this is the example we have for our button here, but go jump into a completely blank frame. Actually, let's keep it simpler and something familiar. Let's go back to our text box we just made. And in the process of playing with our text box, we created this loop. So what I'm going to do is declare a function in that first frame. Prepend it with the word function. Make sure there's two parens to opening, closing, and to possibly have a parameter. Explain in a second, but we're not going to use one now. What we do with the function is inside those brace brackets, we contain some logic, some code to do something. And the reason it's inside that function is we are likely to refer to it again, or just that code's really discrete. But generally, we're likely to refer to that code again, and we're trying to get some efficiencies of not having to rewrite it, copy and paste it over and over again. So I can recall this code, or call again this code. What I'm going to do is in frame 2, reference my first function, semicolon at the end. Flash is going to look for a function with that name and call it for me. So that all it was a trace saying test. So every time we hit frame 2, it's calling that function. So in most cases, our code would be more complex than just one line saying test, but now it's calling it in frame 1, or so 2 and 5, and then if I take the frame rate and go way down from 24 to 2 frames a second, and in frame 2, take this code and call it a bunch of times, you can see every time we come back to frame 2, bang, a whole bunch of test traces come out and fires off that function. So isolate code into the discrete area, we can call and reference it again. Makes sense to everyone that knows what a function is? Head nods. And for those that don't, so far so good? I'm going with that. Okay, so back in our bigger example here, we're actually passing a parameter. So scope is very important in all we do. Functions have to have a unique name in any local scope. You can declare a similar function somewhere else in a different scope and reference it using what we talked about earlier. Also relevant about scope and where actual conventional programming comes into Flash in this instance is variables declared inside a function are only accessible within that function. They die as soon as the function no longer is being called. Not persistent between calls, and they can't be referenced by anything else. What you can do in Flash is use the absolute referencing to say, actually, could you just keep this variable named history at the root stage outside of this function? And that way I can go and get it if this function is being called or not. I can get it from a bunch of spots. So by keeping a variable or action variable in the root, you can make sure it's persistent. Global would be a relevant term in many other programming languages. So in this example, we've got both a variable being declared right when this function is created and one being declared as a parameter. So we can have a number of variables declared as parameters in the function declaration, separating them with commas. In this case, you only need one. And that value, or that parameter, holds a value passed into it when someone calls the function. And the number of parameters we have in the declaration of the function mean every time that function is called, it has to pass that many parameters. So we've got our from button saying where did it come from, I think. And what we're going to do is load up H with whatever was in history. If history equals this string, then we're going to add to it the contents of H and whatever that button passed into it. So a string in this case. Okay. If the from button's name 3, then or if the from button's passing the value of 3, then we're going to do this special else if, because 3 is my lucky number. Otherwise, add to history the contents. So let's look at how this function is called. Each individual button has an on press having a call to that function with a parameter that varies in each. So assuming that button press function wasn't something silly, but something meaningful, we've got a number of instances. Oh, this movie clip's still playing. Got a number of instances, the movie file still playing, referencing this function, and these 5 lines of code are being repurposed every time, meaning we don't have to copy, or more importantly, maintain 1, 2, 5, 6 instances of this same code. We can just call it with 1 line of code, and if we make a change, it applies to everything. And that's how we get this outcome. This one is 3. 3 is our special case. It's a lucky number. We've got that logic embedded in the function that's irrelevant to all of these. Makes sense? That example is up in IASC Sakai. We've got to talk about position and scale and randomization, but I think it's a good time for a break. Is X and Y coordinates. Inside IASC Sakai, we have a section on X and Y movement and key press. We're not going to cover key press this year in AS2. It's there for reference if you want to keep using AS2 and detect keys, but we'll pick that up in ActionScript 3 formally, but it's there if you need to scribe. What is in here importantly, and there's a couple examples too, one for Adobe, one from Curpa. Curpa, great, long-term, taught me my first bit of Flash ActionScript website on the web. Many, many examples. Couldn't recommend it more, except that don't wander into the really old stuff because we hopefully want to deal with the new stuff. Anyways, what is there is ActionScript class reference for the X and Y properties, describes them, and gives you an example. Buried inside that code is an example of X and Y properties. It's actually really simple. The name of the symbol being manipulated here is cursor_MC, and it has a property of its X position and a property of its Y position. So you just send it in a number of X and Y, and that manipulates it. I'll come back to this example in a second. So if I go back to Flash, make a whole new movie, and I'll draw a square because that's the best example. And we're going to turn our square into, let's say, a graphic because it's only going to sit on the stage. Call it symbol 1, and instance. Oh, shoot! I'm caught forgetting that can't give an instance name to a graphic. There we are. Only a movie clip or button or text box. Let's give an instance name as a movie clip. Let's go with box. Box, if I go into a new layer, actions, I'm going to put some actions on that new layer. But let's also choose as a quick way to confirm. There's our instance name box. So very simple movie, 2 layers, one with just our actual box on it, which is a movie clip, and actions with our actual action. Hopefully everyone's already had a chance to notice in our first 5 or 6 weeks that we have X and Y positions for things on the stage. So you see that moving up in the properties right here. If I choose something on stage, I can use the left mouse button or shift left to start doing it by tens to change that position. There's also a width and a height. So we can do negative values, which will push it off the stage. So off to the left is a negative on the X. Off to the top is a negative on the Y. Okay, so double negatives here. Also worth noticing is this is in reference to the reference part of the symbol. So I can move that around inside my movie clip by actually moving the contents in reference to that center point. So double negative, let's bring it onto the stage. That's our goal here. Relatively simple. I'm going to use target pathfinder to get box. And so let's bring the underscore X onto the stage at 200. And let's set the same value for the Y. So in our development environment, box is off to the top left when I run it, placed in about the middle of my movie clip. 200 from the top, 200 from the left. It's really that simple. So it's just a way to reference at the ActionScript level these properties. So far so good. Head nod and such. I will just quickly say 100. Negative 100. Mostly off the page. Okay? Other properties are its width. That's going to affect the appearance of our Y. So right now, it is 140 pixels wide. Let's make it 20 pixels wide. So it's width, underscore width. Super narrow, squeezed down. Same for height. Okay? And to further confuse it, and this is going to rely on the order of operations that or order in which we enter actions. There's a scale value. So this is in increments of 100, so 200%. So we made it really short on the Y, height, and then we made it really big right after that. We'll make it even bigger, which I guess you can't see on the screen. And there's an X scale as well. So 200% of its original dimensions, or current dimensions, last reference, there we go. Okay, so lots of things you can do with this. Obviously, you can marshal your movie clips off the stage and bring them on the stage with your actions. So if there's a scenario in which you need some kind of user input for something to come onto the stage, you can't easily, potentially, use tweening and movie clips directly to have that happen. You could just associate with whatever action you're waiting from the user to then set your X and Y's, bring it on the stage. Other ways you can do it with the mouse, but that's one way you can do it with ActionScript. You can also do things like construct loops to bring scale up incrementally. So if I could use the scale value to grow or shrink something, give a tween-based effect, but it's all ActionScript because it's just changing that scale value. Another example could be that using user interaction, I can scale something up and down to give a depth of field, whatever purpose I have, without, again, needing a tween. I can be exactly responsive to a slider I might create. So that's our usage for X and Y position. We're capturing the full screen in IASC Sakai. We have our section on the math library in ActionScript. It's a way to get a random number. And the random number is between 0 and 1. So a theoretically infinite decimal, not technically an infinite decimal, places of a random number between 0 and 1. So it's highly unlikely you'll ever actually get 0 or 1 back from that random function. So we also use things like round and floor to make meaning out of that. But even if your game, your task, your use case for whatever Flash might be doesn't need a random number, you can use that random number to have random events linked back to it. And that doesn't have to be completely random or a mathematical or scientific definition of random. But if you just want to do something like heads or tails. So here's a simple heads or tails example. And what it's doing is, when you press this button, it asks for a random number between 0 and 1, or whatever it actually chooses the random range in, and then manipulates that result to make it easy to interpret by an if statement. And it's basically saying, theoretically, if the number is 0, call it heads. If the number is 1, call it tails. And then we've got some text boxes to track that. So that's how we're getting random counts in heads or tails. If I refresh this, 2, 3, so I had 3, let's call it tails last time. This time I had 2 tails and 1 heads. All right, a couple people have this open, right? Hit refresh now. And we're all going to press the button at the same time and then call it what we see. Right is tails, left is head. Tails. See? It's random. So that's how we can take a random number, express it in something meaningful to our actual use cases for Flash. Let's look at the code. So here's an example of a math round. Actually, not math random, pardon me. Math.random, referenced twice. Let's go with the most recent. So this is a function declaration with math.random. Math.random gives us our random number between 0 and 1, up to a large number of decimal places. Almost never is that going to be useful to us because it's really hard to use a decimal place that length. We could use some if it's greater than half logic, but a simpler solution is to floor it. Floor is effectively chop off the decimal place. But if we chop off the decimal place of a random number between 0 and 1, anyone know what we get with that every time, regardless of the random number between 0 and 1? 0. If we chop off the decimal between 0.000 and 1, then you're left with 0 because it's something in between the two, a decimal of 0. So that doesn't quite work. We know we can't really use those decimal places. We want to use floor to make it a whole number. The next step is multiply it by something. Often 10, 1. It's a way of controlling the range of random results you want back. If you had a binary situation, multiply it by 2. If you have 3 options, multiply it by 3, and you've got an equal chance of those 3 randomly appearing. So that's our general example of random. If we go and look at the file for heads or tails, so 2 text boxes, tails field, tails is on the right, heads is on the left. Our action script is declare some variables, counting heads and tails. Just put zeros in those text boxes right now and stop using our .text syntax we covered earlier. Our button is on release, give me some random numbers, multiply it by a random number, multiply it by 2. So we've got something between, testing my simple math skills, 0 and 2. So 0.666, 1.8, those numbers between 0 and 2, but not 0 and 2. Chop off decimal, floor it down. That gives us it equal to 1, or sorry, equal to 1 or equal to 0. And then here's our up the number and put it in the text box. Okay? So that's how we can use some randomness to have something expressed as random for the user side. This isn't random enough for a cryptographer, but it's good enough for our purposes. So far, so good. Okay, let's keep adding complexity. You may have this example still up on your screen. If you don't, it's okay. Our x and y. Any astute individuals in the room monitoring what our examples are have a sense of what this is doing?
Wherever your mouse is on the screen, the object will fall.
Exactly. So we're going to chop out the middle of this. Here's a really simple statement. Referencing the mouse, give it the property of hide. So if I copy that and put it on our main timeline for this, you can see whenever I... Oh, thank you, Snowy Mountain Lion, whoever I'm playing or using here. It's completely hidden my mouse. Thank you. Close the window. Yeah, in previous versions of Flash, I have my mouse back. Actually, oh, there it is. Maybe I just lost it the whole time. Oh no, it's gone. It's gone. Command W is for useful there. It's still gone. You can see it tickling the. I wonder what this looks like on the video, and further, I wonder if it's the video that's causing it. But hey, yes. Apparently you just come back to the dock and it comes back. The video is probably like all green screen by now. Anyways, that's probably what's precipitating this. Usually, I expect, and your machines can confirm this for me, when the mouse goes over the flash window, it's hidden. That's definitely how it appears on a web page. When it moves off the flash video, it's visible again. It's what I expect, and it's what should be on the web, and may or may not be what the Flash development environment is doing for us. Simple example. So here's some of that listener terminology we're about to integrate into our own practice, but let's just take this. So here we've got a reference to cursor MC and the X and Y mouse position. So we're going to change this a little bit, but it can be useful to us. So I'm going to use our onClip event and enter frame, because this is definitely something we want to inquire about every single time a frame ticks by. Here's that code we just grabbed off of the internet. Well, cursor MC is not a named instance in our movie clip, but because this is on this movie clip, I can refer to it as this. And then the X mouse and the Y mouse. I believe they are in scope at the moment. I'm not confident with that. We'll find out in a second. But I believe because where we're we can get to the X position of the mouse and the Y position of the mouse. And if we're referencing the right location, which we can fix quickly, this square should follow the mouse around. There we are. So we don't know where my pointer is at the moment, but we can tell when it's on top of the flash file. Okay? So replacing the mouse, if I come down to the dock, it momentarily comes back. And replacing the mouse is as simple as whoever needs to replace it, update its X and Y position with the current X and Y position of the mouse. And if the mouse changes and what you're trying to replace this position with should be moving with the mouse, you need to update that, find the method to update that information. It won't help you to call that once in the first frame and then never call it again. The mouse is unlikely to ever be in the right spot during the first frame, and otherwise it's your last chance to check it. Set up a listener, which is the example on the web page, the one we'll be moving into, and an action script to land. We can just say every time the mouse goes by, or the frame goes by, change the X and Y position of the mouse. Good, good. Okay. Let's go and look at some movement again. Do I have random movement revealed? Let's actually stop. Our example for looking at X and Y position and random numbers has to do with actions that change the X value of this movie clip here. And the increment which is changed by is random. So we'll grab this file from Sakai. And it's hard to keep my mouse here. Okay. On release, we're changing the scale of, that's all that's happening actually, just changing the scale of our movie clip here. So on the first instance, then subsequent, got increments. There we are. So increment gets changed in the first frame. Perfect. Okay, so our first frame, trace. Where is my star, this instance name? Trace out where it is. Just for our development purposes, we know where it is. Set it to 100 X and Y. So you can see it starts here. You can put it there, but it's going to start on the left-ish. Now where is it? Tracing it out to the output box as well. What's the current scale? Let's just divide it by 2 right away. Then let's reposition it again. Take a random number, multiply it by 550, the width of our stage. We could also do stage dot width. Whoa. I don't know how that prompted. I'd hit save. Stage.width gives you the width of the stage. So you could change it yourself if you wanted this more robust and more applicable to more examples. So we're going to set X and Y to a random position inside stage width divided by its width. And then our increment. We're going to choose an increment to move the flash, move our movie clip by every single time we get back to frame 2. And we're using a number that could be like 4.656 blah blah blah. We can only move by actual whole pixels. We could wrap it in a math.floor But Flash will just ignore the decimals for us. But as a best practice, you may want to wrap it in a math.floor or round, which has its own principles, but floor is the most predictable or simple to work with, I should say, option. So we're going to change the x is positioned by the increments every time we get back to this frame. And frame 2 says go to 1. So we've set up our timeline-based loop. So every time we get back to here, every other frame, where is my star now? Make it where my star is now plus that random increment value. We get a new increment by just saying reset the scale and go back to frame 1 so that all these actions, most of them are frankly irrelevant, get replayed. Most importantly, new value for increments. Okay? So you can see the increment value being traced out, the different x and y positions being traced. So there's an example of using x and y for random positioning. So far, so good? Okay, that's up in IASC Sakai. Is it of interest to take a moment to write your own random movie clip? Looking at the time of 3 and a bit hours into our class, we get the sense that no, you don't want to do that. Okay. Let's apply one last example here. Now is build a really simple movie clip that takes our ideas of functions, what we know about x and y, and makes something a little more complex. But again, line by line should be something simple, which is why I grabbed this file and pre-written it for us. We'll work through this problem, and then we can successfully examine it and call it an evening. So what I'm going to do is get myself a character inside a new ActionScript 2 movie clip. So I'll draw a little character. And convert this into a movie clip. Do one movie clip. We'll reuse this guy over and over again to save us having to do more. And 2 clicks in there, and let's add some motion, some interaction to this character, just so we have something interesting to work with. I'm going to distribute that to a number of layers, and let's make a quick motion tween for his arm. Fine, make that symbol. I'm sure you'll do a good job with it. Trying to pretend I can keep you guys upbeat and focused when clearly the late hours affecting me as well. But everyone's doing great. So that's some quick little path for the arm. And we'll do this one as well. Insert frame, motion tween, yes, okay. And just do a little bit of waving again. I don't know if that's going to loop smoothly, but I'm going to assume it's fine. The head, leg, and torsos need to come along with us. So there's a really simple animation. We can reuse that over and over again. Okay, so that's going to be our simple movie clip with our dude. We're going to leave that as some really, well, an example of animation that makes sense to do with a tween, because it was simple, quick, motion tween appropriate. But I want to do some complex, call it some shaking of our individual using that x and y coordinates and some randomness, and do it all through a function. so that once I first applied it to this individual character, I can build it off on into the rest of the movie and more characters, pardon me. So let's get a long example to work with here. 375 or so frames. So I'll give it a number of times to cycle through before the frame actually goes, or before a movie clip actually returns. And let's make an actions layer. And this is where we're going to take the file I already grabbed. Let's cut and paste it and apply it to our simple example of simple example as far as our mouse inputs, more complex with our actions. Let's talk through this. So in our first frame, we're declaring a we don't even need our score. Declaring our variables. What we do first off is declare arrays. Covered in Rosenweek chapter 2, declaring arrays. There's the syntax again, assuming we've got good knowledge of arrays and variables. If not, if arrays are confusing to you, a variable has multiple positions in one variable, then happy to discuss that with you. Majority of our classes, our previous assessments, knew what arrays were, so we're going to move through that, but if it's obscure to you, happy to explain it. May even bring in diagrams. Also declaring a variable for instance num. We're going to use that as a number to refer to when we make way more instances of our symbol. We got to keep track of them some way. One way is just to give them a number as soon as we find out about them. That's what we're going to use. So we're going to assign every future symbol instance of our dude we just created its own number, and that's how we're going to issue instructions to it and know what values we saved about it in our array. This gives everything we apply this function to its own position in our global array about its x value and its y value. So at first here we have one character. It's going to get the value of 0, I believe, 0. Actually, 1. And we're going to pass that into our function here in the second position. In the first position of this function, we'll give a reference to ourselves. We can send this all back to the calling movie clip. So I'll explain what happens from here on down in a bit, but let's go over to our movie clip so we can make some calls to this function. So here's that script commented out down here. The movie clip, as soon as it shows up on our movie, it's going to have a load event. It's declaring a variable called me, and that global variable on the main timeline, instance num, that was set to 0, add a 1 to it. So you're declaring a variable local to this instance of a symbol called me, and you're going to assign into it whatever was in instance num plus 1. This is how we're going to ensure that every time a new copy of this dude shows up, we get a unique number to store information about them. So far, so good. Easy when it's explained. We'll see how it is when applied. Then we're going to go into my own movie clip and jump to a random frame. So let's just double check. We don't have 20 frames, so... And now we do. So what it's going to do is on load... Oops. On load, drop this movie clip in one of its 20 frames. Don't start from 1, like you would by default, or randomly start from 1, but there's a 1 in 20 chance it's going to start from its first frame. So that's going to give us a difference every time it's loaded, starting position for our person waiting. That's why we got our animation to distinguish that. So far so good. On clip event, here's that function that was just declared. It's back on the main timeline, so we're using our absolute reference to root. We're saying call the function named move my movie clip. We said there's going to pass two parameters. This. So whoever I am, tell it who I am. This is where this alias for yourself of this is really useful. You can cut and paste this over and over again, never give an instance name, but because you're passing this, Flash internally knows it has its internal instance name for that. It can reference it. You never had to write a named instance name. You're just saying, I'm passing this value of myself. That pointer that's being passed is good enough for the function to deal with it. You or I, unless we start doing some tracing, wouldn't even know how Flash referred to that instance, and it doesn't matter. Second, me. This variable we declared here, our unique number to keep track. That's everything that's happening on the movie clip. Back to the function. We're just effectively making this movie clip shake and move across the screen. So we're going to what we're going to do here is see if our array we declared in the position of the value passed in, so we called it me locally, it's passed in as pause position, has been set before. And what we're storing is the amplitude for our shaking. So this is a really crude syntax, and it's the simplest way to do it without having testing for set and unset, which you don't need to cover yet. Is there something there? If not, it's for the first time we've done this for this particular instance. Set a value that's randomly generated based on the amplitude. Random number times amplitude, which is 5 right now. I could have hard-coded 5. See, I'm referencing it twice. Easier to keep it in a variable, and I can mess with my animation or my shaking amplitude really easily. Multiply it by random, floor it out. Same for x and our y. So we're storing in the array an x, y amplitude for all of the things that could call this function. Tracing out who called it, so we get our this reference, we'll know it based on that, and the number that they were assigned. This is our keeping track. This is our movement. So this is called, remember, every single time a frame goes by. So if we're just taking some random direction change right here and saying, hey, if you get a random number and it turns out to be 1 in 5 chance, just jump my position. That should really get some shaking going on. So use a little Elvis that I regret doing. We've also got every frame, if the x is greater than or equal to the stage width, take away the movie clip width, then you know what, I've hit the edge. I'm at the stage width if you include the width of my movie clip. So not just that center position, but the actual width of the movie clip means it's about to go off the page. The other reason we're storing our amplitude in the variable is now we can change it. If we multiply something by -1, what was previously a positive number being added on to the x position or x position, every single time a frame ticked by, it's now a negative number. We've reversed our direction. Okay? So before we were going x moving across the screen to the right. Now we've detected that, oh, this value is greater than or equal to the width of the stage, and then accounting for my actual width. So change the amplitude from adding to x to subtracting from x, and we'll move back away from the edge of the stage. So far, so good? Okay. Need to do the same thing for the left side of the screen. If you hit 0, turn back around, multiply a negative number by a negative number, you get a, someone help me? Positive number. Excellent. Then we've also got, so here's where we actually apply that. believe. Same thing for the y, based on height. And then actually applying that. So this is the storing the position. This is the actual applying it to the x and y. Applying it to the x and the y. Get the value, apply it. And this is the code I copied over. That's the whole function. So every time a frame is entered on any one of these movie clips, I only have one so far, we call this, pass it its reference to the dot notation, its instance name, which we don't have to actually give it because it's just referenced by this, and Flash has its own internal referencing for it we don't have to worry about. And that unique number it's given itself by adding 1 to this global variable. So that gets us our shaky character. So he's now hitting that if condition of, oh, my x has gotten too small, I have to turn around. The amplitude's probably a little small for him to not make it back. But he's also got random up and down, so he's getting this total shake movement. So because it's all isolated inside a function, if I go down my timeline, and let's add more. So I've got my keyframe here. Worth noting, something that we could have actually caused myself a big headache with. Because there's a keyframe, and because of when I added it, the actions associated with the movie clip on this keyframe didn't transfer to that keyframe. It was blank when I added that. I hadn't cut and pasted in my actions. I'll repaste them, but heads up, that's something that can happen in ActionScript too. If you add a keyframe, what's associated on the movie is just as effective as anything else that happens when you add a keyframe. One more reason why ActionScript 3 simplifies this. But let's, now that we've got this character here, he's got this great, oh, is that on, that's on the, you can see, that's on the frame, not our individual. Cut that, here goes the A. Now it's actually on our movie clip. Okay, crisis averted. Just go ahead, hit copy and paste, and paste, and paste, and paste, 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 and start giving these guys some unique locations. With this method, you can see this code came with it. So now, when it increments this number, it's going up to a total number of 7 or 8 total unique positions, so it can keep track in its array of 8 different positions. I'm going to add some frames to the end of our movie clip. Let's go down the line here. I think about twice as much would be around the 700 mark. So we got applying the 1. Then, what did I say, 370 or something like that? Look at all these instance names, the unique internal Flash instance names being called there. Oops, let's get back to our running Swift here. So you can see them being called. And that function, because we've isolated the animation to the function, is being really seamlessly reused. If that amplitude is going to be changed, because I've clearly got a problem, I can change it in that one function. It's going to solve that issue for all of my shaking characters. And because I used those variables to store a unique number for every single individual, it holds a way to keep their current amplitude and position and work with that. So we've addressed the issue that variables are constructed and destroyed all within that function by storing them external to the function. And this works to scale. So let's go back to the right file here. And where's my table? Here's my table. So I'm down at 375, but it would work right here at the keyframe. Copy, paste, Paste. And that's just paste again. And this abstraction will make sure that they can all get a unique reference. While I'm at it, let's just add another layer here. And import. Let's go some additional music to the library here. Dump this on the stage. So now it's going to play, and then I get once again. There you are. So I think that's the best example I could do of that. And I'm pretty well assured you were the last group of students who will ever be able to show them that example because it's not going to be relevant 12 months from But it's a solid example. I'll post the code online. That's the end for tonight.
Yeah, you should definitely post that.